Hey everyone, welcome back to our NumPy series. This is video number 8, and today we are diving into a super useful concept, aggregate functions in NumPy. So these functions are the tools that help us calculate things like sum, average, max, mean, variance, standard deviation. So basically they take multiple inputs and give one output. That is why we call them aggregate functions because they give one value in the output. In this video, we'll not only learn about these functions, but we'll also understand how they behave across dimensions. Because as we all know, NumPy can be multi-dimension. NumPy arrays can be multi-dimension. So aggregate functions, as we have discussed, they help us summarize the data in arrays. So they are very useful, especially when we are working with large data set. Now, these aggregate functions work on 1D, 2D, or 3D arrays, and their output depends on whether or not we use access. So let's say we have marks of a student in 4 subjects. So this is the marks of students, let's say Aryan, in 4 subjects. Let's say math, science, social studies, and Hindi. Now, if we were to calculate the total marks, we can simply use the aggregate function sum here and pass the marks, and it will give us the total marks. Similarly, if we want to calculate the average marks of Aryan in the 4 subjects, we can do something like this. If you want to see the maximum or the minimum marks scored, we have the max function for the maximum marks and min function for the minimum marks. So simple enough, with just one line of code, we were able to get these values. Now, let's say we have a two-dimensional array. So let's create an array. Let's call it marks underscore 2D. Now, in this array, we have, let's say, the first dimension is the student. So this is marks of student 1, 2, and 3 in 4 different subjects. So the second dimension is the subject. So here, the first dimension is students, and the second dimension is subject. So that means 85 here is the marks of student 1 in subject 1. 80 here is the marks of student 2 in subject 2. 65 is marks of student 2 in subject 3, and so on and so forth. So this is a two-dimensional arrays. Now we want to get, let's say, marks, sum of marks per subject. So if we simply do sum and pass marks underscore 2D, let's see what happens. It basically goes ahead and sums all these marks. But what we wanted instead was we didn't ask for total marks, but what we were looking for is the or sum of marks per subject. Sum of marks per subject. So we have a parameter for that, which is called as access. Let's set it to 0 and let's see what happens. Okay, so we are getting 4 values, and these 4 values correspond to the total marks per subject. So the first value is 85 plus 70 plus 95. That comes out to be 250. So this is the marks, total marks scored by the 3 students in the first subject. This is the total marks scored by the students in the second subject, and so on. Now, what's going on with this axis? So axis is a parameter which refers to the dimension along which the operation is to be applied. So when we said axis is equal to 0, what are we essentially saying? That this operation sum has to be applied for first dimension, which is nothing but our rows. That is what this axis is equal to 0 means. That means we want to operate down the columns because we want to sum along this axis is equal to 0, which means that we want to operate down the columns. We want to collapse this row. We want to get one row and we want to operate down the columns here. So we want to operate down the columns. Now, when we set axis is equal to 1, what are we saying? We are saying that we want the marks, sum of marks or total marks per student. Because axis is equal to 1 means that we want to sum the second dimension, right? We are referring to the second dimension. We want to collapse the second dimension, which is our columns. Second dimension, which is columns. That means we want to operate the rows. We want to operate across rows. Okay, so this is the total marks in all the 4 subjects combined, scored by student 1, this is by student 2, and this is by student 3. Now imagine a 3-dimensional array. Let's call it marks underscore 3D. Now, in this array, what we have is, it's a 3-dimensional array, as you can see. Always look at the opening brackets, as I always say. So it's a 3-dimensional array. The first dimension is the class. So this is for class 1. So we have 2 classes, let's say class 1 and class 2. These are the marks of students of class 2. So the first dimension is the class. The second dimension is the student. So this is student number 1, student number 2, 3. Likewise, for class 2, this is student number 1, class 2, student number 2 of class 2, and student number 3 of class 2. And these are the marks in 4 subjects of student number 1. So 80, 85, 90, and 75. So that means first dimension is the class, the second dimension is the student, the third dimension is the subjects. Now let's say we want to average marks per student across all subjects in each class. So average marks per student across all subjects in each class, right? So axis would be 2 here, third dimension. So we'll say NP dot mean marks underscore TD axis is equal to 2. Axis is equal to 2 means third dimension, right? Because if you see here, axis is equal to 0 means first dimension, axis is equal to 1 means second dimension. So axis is equal to 2 means third dimension. Okay, so this will operate across all subjects. average marks per subject. So this is giving me average marks per subject. So it's telling me 82.5 is the average marks secured by students of class 1 in subject number 1, and so on. Now let's say we want overall average per subject across all student and classes. So that means what are we looking in the output? That for, let's say, subject 1, what is the average for subject 1 across all students and classes? So all the students and classes, what is the average for subject 1, right? So average marks, let's say M1 or whatever that number is. Let's just keep 100. Likewise, for subject 2, subject 3, and subject 4, we have 4 subjects in total. That means, how do we want to sum it? We want to sum it across axis 0 or axis 1 and axis 2. We want to collapse class and student and keep the subject. So what do you want to do here? We want to keep the subject. For each subject, we want the average marks. That means we want to collapse class and student. Class, as you all know, is axis 0. Student is axis 1. So because we want to collapse across 2 dimensions, class and student, we can give axis is equal to 0, 1. So let's try it out. And this is what we are getting. So this is average marks per subject for all the student, all the classes combined. So this is for subject 1, 2, 3, and 4. So let's recap quickly what we have learned today. First, aggregate functions make it easy to summarize our data. Axis is equal to 0 means first dimension. So we go down, right? We go down the rows, we do it column wise, we apply the aggregation function column wise. If axis is equal to 1, we go across, we apply the operation row wise, and axis is equal to 2 for 3D array, we go across the depth. So the axis number refers to the dimension you are collapsing over. So here it means we are collapsing over first and second dimension. So what will remain in the output? The third dimension. We'll get average or the mean marks in the third dimension, which is our subject. The average marks per subject. Here we are collapsing over axis is equal to 2. Axis is equal to 2 is subjects. So we are basically calculating average marks per student will remain. So this is student, which is second dimension. The classes will remain. We are not collapsing the classes. We are collapsing the third dimension, which is our subjects. So we are basically calculating the mean of subject for each student and each class. Leave your questions in the comment. I would love to help. Thank you for watching.